What is a function? Well, a function is primarily a relationship. For example, you might explore the relationship between time and cost, where, for example, after a flat fee of $5, it might cost you $20 an hour to rent something. And we can even see how this relationship plays out with a couple examples. If we compare time, for example, in hours to cost in dollars, we see, for example, that after 1 hour it will have cost $25. After 5 hours it will have cost $125. And we could even display this information, this function, this relationship graphically, showing here that over time the cost will rise, starting at $5 for no hours and going up from there. And this is a nice way to demonstrate that there are different forms that you can use to display a function. You can, for example, talk about a function using an equation. You can talk about a function, or at least demonstrate what's going on in a function using a table of values, and you can also show what's going on with the function by graphing it. Now, most often, of course, our functions that we deal with in math class aren't about real-life applications like time and cost, but they just deal with the relationship between two variables, which often represent some kind of number. For example, we could talk about the relationship where x plus y, if x and y are two numbers, if we want to define the relationship as when you add them together, they add up to 5. That's a relationship. The two of them must always add up to 5. And so you can see here we have a function defined by an equation. We could also create a bit of a table of values that says, well, okay, if x is 0, then y must be 5. If x is -2, then y must work out to 7 in order for them to add up to 5. If x is 4, then of course y must be 1. So here we have the function in the form of a graph, the function in the form of a table of values, and of course we can graph this relationship. Now, you're used to graphing in the form y equals mx plus b, and of course if we just rearrange the equation we have, we could actually see it in y equals mx plus b. We could also, of course, graph it by finding the x and y intercepts. There's different ways you could graph it. Maybe one of the easier ways is to rearrange it to this form, where you would see that m must equal -1. It's not immediately obvious, but that negative sign and that invisible 1 means that we have a rise of 1 over 1, x-intercept of plus 5, and so we could just graph this relationship, and it would look something like this. Right, I guess if this was 5 right here. So a function is a relationship. You can show it using an equation, a table of values, a graph, a solution. A solution is something that makes a mathematical statement true. For example, the mathematical statement x plus 3 equals 5. We would probably say that this has a solution. It has one solution, and the solution is that x must equal 2, right? That makes it true, because 2 plus 3 is 5. And in finding the solution, we have what we say, we have solved the equation. Now, what makes a function a relationship, and not just an equation, is that it has actually an infinite number of solutions, because one solution to this equation, or this function that we have here, is that x could be 2 and y equals 3. That is one solution, but it's by no means the only solution, because x could be 1 and y could be 4, and x could be -10 and y could be +15. There's really actually an infinite number of solutions, and that's why we define it more about the relationship. And indeed, a graph is really just a picture of all the infinite number of solutions that you could just put up, all the x and y coordinates, we call them, all the x and y pairs that will make this true. There are also, just going back to equations, there are some equations that could actually have more than one solution. Just a quick example, and we'll look at more of these over the course of this course. For example, x squared equals 9 could have two solutions. One solution is obvious, that x could equal 3. Maybe a less obvious second solution is that x could equal -3. They're both true for this. So a linear system, then, is actually two or more linear functions together. For example, here's a linear system. X plus y equals 5, and y equals 2x minus 1. Now they're both linear functions. They both have two variables in an equation, so they're both about a relationship between the same two variables. Often we just call them the linear function 1 and the linear function 2, or line 1 and line 2 in the system. Now, linear system 1, if I was to quickly make a table of values to say, okay, well, what things are solutions for function 1, we could fill it in, say 0, 5, 1, 4, 2, 3. I think all of these pairs of numbers make this particular solution, this particular function, true. And if I was to fill out a table of values for the second function, and I said, well, if an x is 0, I guess y will turn out to be -1. If x is 1, then y will be 1. If x is 2, then y will be 3. And if x is 3, and I'm just filling out some of the actually infinite number of solutions for both of these functions that are in the system. Now, the solution to the system is that coordinate that is true for both functions. And just by looking at the table of values, we see, oh, the solution to this system must be that x is 2 and y is 3. Or just written as a coordinate, the coordinate 2, 3.